In 1965, a man entered a NASA vacuum chamber. His spacesuit failed. The pressure around him vanished, and the last thing he remembered was the saliva on his tongue beginning to boil. About 14 seconds later, he blacked out. He survived. So what would happen if you were thrown into space for 10 seconds? Let us find out. And no, you would not explode. The airlock opens. 10. Air blasts out of your lungs. If you hold your breath, the expanding gas could damage them. Your best move is to breathe out, which feels like a terrible strategy in a place with no air. 7. You are still awake. Moisture on your tongue and eyes begins bubbling because there is almost no pressure around you. 4. Your body starts swelling. Your skin holds everything together, but your brain is quickly running out of oxygen. 1. The airlock closes. Pressure returns. You are alive, but only just beginning to understand what happened. Hollywood treats the human body like an overfilled party balloon. Space removes the pressure around you, but your skin and tissues are strong enough to stop your body from bursting. You would swell, you would look deeply concerning, but there would be no dramatic explosion. Apparently, reality has a smaller special effects budget. The moisture exposed to space can boil at body temperature. Your saliva, tears, and water in some soft tissues are vulnerable. But the blood inside your vessels is still being squeezed by your beating heart. That pressure initially keeps it liquid. So the phrase, "your blood boils in space," is catchy, horrifying, and not quite true. Space is cold, so surely you become an ice statue immediately. Except, space is mostly empty. On Earth, cold air carries heat away from your skin. In space, there was almost no air to do that job. You would eventually lose heat, but freezing is not the emergency during these 10 seconds. Lack of oxygen is. Your lungs are empty, and your brain is burning through the oxygen left in your blood. Your vision begins narrowing, thinking becomes harder, your coordination starts failing. At around 15 seconds, you would probably lose consciousness. That means our 10-second astronaut has escaped with roughly 5 seconds to spare. Not enough time to celebrate. Barely enough time to regret not choosing accounting. If this is making space slightly more terrifying and interesting, please consider liking and subscribing. It helps Kliqora grow, and you can do it without opening an airlock. Now, back to that NASA vacuum chamber accident. Test technician Jim LeBlanc was helping test spacesuit equipment when the pressure hose disconnected. Video from the incident shows him losing consciousness as people rush to repressurize the chamber. His exposure lasted longer than our 10-second experiment, yet after pressure returned, he recovered without lasting injury. That does not make vacuum exposure safe. It shows that immediate rescue matters enormously. The body can survive the opening seconds. It cannot survive them indefinitely. Now remove the rescue. At roughly 15 seconds, you are unconscious. With no oxygen reaching the brain, damage begins building. Your circulation eventually fails. After 1 or 2 minutes, you are dying. There is no perfect universal stopwatch. Bodies differ, and scientists, quite reasonably, do not test this by throwing volunteers into space. But the outcome stops being mysterious very quickly. Space does not need to explode you, freeze you, or boil every drop of blood. It simply switches off oxygen and waits. So, could you survive 10 seconds in space? Possibly, if you breathed out, avoided serious lung damage, and were repressurized immediately. You would swell. Exposed moisture would boil. Your thinking would begin failing. But you could survive. that may be the strangest part of all. The human body can briefly endure a place where humans were never meant to exist. Just do not make it 11 seconds to prove a point. And if empty space sounds dangerous, our next destination is considerably less subtle. What would happen if you fell into the sun?